Hi, the merge sort is one of the sorting method which is applying divide and conquer algorithm to sort out the given array of numbers. Here, which is done by using the recursive algorithm, which is dividing the list into two halves. For example, when you are taking the array with the n size, then it is dividing by n by 2 and n by 2, two halves. Again, this is dividing by one more two halves, like that again this is going to be divided by one more two halves until we are reaching the single element in the given array. For example, you look at that, this is dividing by two halves, again it will be dividing by two halves. After that we will merge the shorted elements into single array, right? So this is about the merge sort. Here, when we are applying the merge sorting algorithm, which is taking this statement is order of one time execution, and the merge sort here sorting the numbers two halves. Okay, it is taking the n by 2, that is the half of the elements from the size n. Then another half, this half is taking another t of n by 2. So again and again we are okay, this will take the n by 4, this will take the n by 4. So we will keep on doing this. So after getting the t of one single element, then we are trying to merge it. So finally for merging also we are taking the time consumption. So finally for merging all the elements, combining the given elements, we will take order of n. So we will calculate this now. 2 times of t of n by 2 plus n plus some constant amount of time. This is the recurrence relation we got for the merge sort. So based upon that, here when n equal to 1, so that means if your array is having only one element, this is the array, then it will consume constant amount of time. That is, for example, 1 unit of time or 2 units of time, like that. So constant amount of time. But if array is having more than one element like this, then it will take here 2 times of n by 2 plus constant amount of time, this one, then constant number of steps whenever the n is greater than 1. So now solve this recurrence relation to get the time complexity of merge sort. So for that we are taking t of n equal to 2 of t times of n by 2 plus constant amount of time. Then we are substituting the n by 2. So because here we are going to use the partition like n is divided by two halves, then again this will be divided by two halves. So like that it will keep on go until single element in the list every sub problem. So now when you are substituting the n by 2 in the place of n, you will get the 2 times of n by 4. Here also you will substitute the n by 2, you are getting the n by 2. Then you substitute this all the entire term into the equation number 1 here. So this 2, then this term we are substituting here, 2 times of n by 4 plus n by 2 plus here we are substituting this n. Okay, this n is this one. Then now we are going to find out the pattern here, 2 square. Then we are having the here 4, this is also taken as a 2 square. Here this will be cancelled, so we are having the n plus n, so we are getting the 2n. So this pattern gives you for the when you are taking the I times. So if you look at that, this will be taken as a I. So now you can take 2 power I t times of n by 2 power I, and added with I plus I n. Okay, now in from this term, if you are keep on do it until you are getting the single element in the subarray, we will get the initial condition is t of 1 equal to 1. So from this condition we can say when we will get the 1 here for the t of 1, the substitution value is 2 power I. When you are substituting the 2 power I, you will get the 1 t of 1 for this term. So from this n by 2 power I equal to 1, then we can define n equal to 2 power I. So when you are applying the logarithmic in both sides, then log n becomes log base to 2 power I, right? Then it will become, this term will become I into log base 2 power 2, so it will become 1 now. So I value is now log n. Now the this value is substituted in this equation, right? So when you are substituting that in this equation, t of 1, okay, this is n times of t of 1, right? When 2 power I, t of 2 by 2 power I by 2 power I, then plus I n. So in this equation you are substituting these values what we have found here. So here when you are substituting this 2 power I, this 2 power I is here n, this value, right? So then when you're substituting this value, now n times of then t of 1, so this is t of 1 plus here I value, what is the I value here? Log n. So I is the log n, then this n, so that will become, so that's what given here, n log n, here n times of t of 1, then t of 1 is already we know this is 1. So now which is your n, then n log n. So finally we will as a order of growth function, we will ignore the lower order term, we will take the higher order term n times of log n. So this is the time complexity of mid short n log n. Thanks for watching.